Okay, but are there any questions on this stuff? I know this is not easy. I understand that, but so I want to make sure everyone understands. That's my goal. All right. Well, let's do another one, though. Okay. All right. All right, so for this one, same, it's actually very similar. We want to find this sum, and we're going to simplify. Well, notice that 3x plus 2, right? That's already, that's already irreducible. It's factored. You can't factor it anymore. Mostly because you have x to the 1 here, and 3 and 2 have no common factors other than 1. Now for the second one, the denominator is 4x squared minus 1, okay? So from here, we can factor that, right? It's just like from before, actually, right? Because 4 is 2 squared. X squared is x squared. 1 is 1 squared. So in other words, we have a difference of 2 squares here, right? Actually, one more step. I'll say that again in a second. From here to here, we can use our rules of exponents, and we get 2x squared minus 1 squared. Now we have a difference of 2 squares, right? Just like before. We have this rule. And using this rule, we can write this denominator as 2x minus 1 times 2x plus 1. In other words, we factored it. So now these denominators are factored, which is good. And because they're factored, we can now get the LCD, right? We have the irreducible factors, right? We have 2x minus 1, 2x plus 1, 3x plus 2. And each factor, their only exponent is 1, right? Normally you get the greatest exponent, but each of them only have an exponent of 1. So the LCD would be 2x plus 1 to the first times 2x minus 1 to the first times 3x plus 2 to the first, which is the same as this, as you can see. Okay, now, so from here, we need the denominators to become this. These denominators must become the LCD. So for the 4 over 3x plus 2, we're missing something. We're missing 2x minus 1 times 2x plus 1. No big deal. Let's multiply it. But remember, what you do to the bottom, do to the top. Okay? As you can see. 2x minus 1, 2x plus 1. Okay? And from here, what do we get? Well, we're going to get 4 times 2x plus 1 times 2x minus 1 divided by this. I mean, you could actually FOIL the numerator now if you wanted to. I didn't, but that's okay. Okay. So from here, we have 5x plus 3, 4x squared minus 1. Okay. 5x plus 3 over 4x squared minus 1. So now what are we missing? Well, we factored the denominator as above. We had this. We are missing this 3x plus 2. Okay, let's multiply the bottom by that. But we also have to do the same to the top, right? Got to keep everything algebraically the same. And so we end up with this. So altogether, so far at least, this sum becomes this sum. Okay, that's good. So from here, what do we get? Well, we have to add the numerators, right? Remember, the denominators we don't add. Okay? You don't add them. The numerators we do add. And of course, since we want to simplify, just like before, we have to actually carry out these products. Okay. So when we do that, we get 4 times. If you multiply these two, really from the previous slide, where is it? Oh, right here, right? 2x minus 1 times 2x plus 1 we saw is 4x squared minus 1. So the first product is 4 times this, and we'll get that. For the second product, we FOIL. We get 15x squared plus 5x times 2. What is that? 10x. 3 times 3x is 9x. 3 times 2 is 6. Okay? And if we do, if we do 4 times this difference, that's the same as 16x squared minus 4. So now we have all this in the numerator. So what do? We combine like terms. Although I did that up here, we had 10x and 9x, right? So that's 19x. Now we have 16x squared and 15x squared, right? We're going to combine those. Minus 4 and 6, we combine as well, and we get this. So we get this. Okay, so this is what we get. Now, are we done? Well, no. Because we have to see if this is simplified. We have to see, in other words, if the numerator has any factors in common with the denominator. And we're going to use the same thing as before, the factor theorem. So I'm going to take capital F to be this here. And I'm going to apply the factor theorem each time to each factor. To each factor, I'm applying this factor theorem, meaning I'm going to determine if capital F, our numerator, maps something to 0. So for 2x minus 1, right? 2x minus 1, comparing. A is 2, B is 1. So we want to know, does capital F map 1 over 2 to 0, right? This is what we're doing. Yeah, maybe this will help. See if I can. We have A times X minus B, right? A is 2, B is 1 in here. So we have F of 1 over 2, where again, this is our F. And if you calculate that directly, I did this through Desmos, you get 19.25. You could use a calculator, so. Okay. For the 2 times x plus 1, same idea. We have A times x, but remember, we want minus B, right? We don't have that yet. This is addition. Addition is not the same as subtraction. What we can do is write the top as A times x minus B, but we take the top though and write it as 2x minus a negative 1. So now we have subtraction. We have A is 2, B is negative 1. So capital F at negative 1 over 2, right? And then we calculate that, and we don't get 0 either. So we still have that. I mean, I could have written this factor theorem for AX plus B. The only difference would be F of negative B over A. But again, I just want you to be able to visualize it from the way it's stated here. So for this one, same idea, right? We want AX minus B. We don't have that. We have addition. So what do? Well, we can write it as subtraction, right? If you have 3x plus 2, that's the same as 3x minus negative 2. Minus negative 2. So in this case, we have A is 3, B is negative 2. So we have f of negative, and we get this. And we don't get 0. Basically, the point is, by the factor theorem, right? Here we get f of a half is not 0. So 2x minus 1 is not a factor of the numerator. F of negative a half is not 0. So 2x plus 1 is not a factor. And same thing with 3x plus 2. It's not a factor. So that tells us the top and bottom have no common factors. I mean, you could have used the AC method to try and factor the numerator. You could do that if you want. But, that's the AC method, so you would have to do factor by grouping, which is, I know it's fun, but, this was also fun.